Alright, so the following lesson is for grade 5. It is a science lesson on the new next generation science standards, particularly looking at gravity. So this, I chose a project-based learning challenge, and the objective is for the students to solve the problem and create a parachute that will allow a hard-boiled egg to land without cracking. Students need to have the knowledge of gravity and other forces on Earth, such as air friction, wind. Students need to fully understand that without assistance, objects accelerate or speed up as they fall to Earth. And when a parachute is added, the rate of acceleration decreases, and in some cases, the object will fall at a constant speed. As an object lands, once it has been dropped from the sky, it will fall to the ground at a higher rate of speed than if a parachute was attached to the object. The parachute slows the speed of the object because it catches the wind. As the object lands, it needs to be protected so it is not destroyed. By cushioning the fall, it lessens the effect of gravity on the object. So let's take a look at the PBL. So to start off the group, the first part they do is they're going to design in form teams. So we're going to separate the class into groups of 4. They're each going to have expert roles, so each student will have a role within this, but first we're just going to separate them into groups. We're not going to assign them roles yet. They're going to first read the entry document, which is right here on the parachute drop. So it gives them a little bit of background story and goes through what their scenario is. It goes through a few stages and then gives them a little background on what they will be doing for the entire project. And it tells them who they're going to be breaking up their team into. So the 4 roles are going to be the design engineer manager, the materials engineer role, the parachute deployment engineer role, and the graphic design engineer role. So those are the 4 roles that they'll have. Okay. The next, they'll be actually given their problem. Okay, so they're going to show the entry event video to the class, which they have on the website. And in their group, students are going to read and discuss the entry document that I just showed you. As a teacher, you're going to direct the students to highlight and take notes in the margins of the page, just to give them some ideas for how they're going to be setting up their project. And then individually, they're going to complete the need to know section in their lab notebooks, which you can see right here. So for know, the criteria is they're going to draw and design 2 parachutes that will keep the hard-boiled egg from cracking. They're going to draw a detailed scale drawing or blueprint of the 2 prototypes. They're going to present materials in a list or table that details safety considerations of the materials. And they're going to decide on only one to build and test. For the constraints, there's only going to be 1 egg per team and 1 parachute per team. The parachute and the plastic egg with pennies cannot weigh more than 80 grams. And we will have 2 days to complete the project and 3 minutes to present it. What they need to know is, what is the engineering design process? What materials can we use to build our parachute? Where can we find information on parachute? How will this assignment be graded? Can we build both parachute designs and in order to test which one is more effective? So that's what they'll be copying into their journals. When recording the questions on the T-chart, you should leave space between each one so that the answers can be recorded. This is just to help them with the organizing and just have them have a chart so that they can have it visible during the entire project-based learning process after we review the engineering design process to emphasize and reiterate the steps that they do to design a solution. For the 3rd step, as a whole class, there's going to be a workshop, so they're going to discuss the purpose and benefits of a parachute. First, they'll take notes on the purpose of a parachute and how it slows down the effects of gravity on an object. Then I, as the teacher, is going to demonstrate 3 different sizes of parachutes attached to a toy of some sort and drop it off from the ceiling, which was about 8 feet tall. Students are going to record in their journal the time it took for each parachute to land and see the differences. Students should observe that depending on the size of the parachute, the toy takes a longer or shorter time to land because of the parachute catching more or less wind, allowing the effects of gravity to be slowed down on the object. Once the activity is complete, they're going to brainstorm a list of real-life situations where a parachute is imperative and needs to slow down the effects of gravity. And then these are just some of the mini workshop pages that come with it. So this just goes over their roles in the mini workshop and what they'll be doing as we test and they take notes. And there's one for each role. And then the step 4 is expert group workshop facilitation. So after the students have had the whole group lesson on purpose and benefits of a parachute, they're going to look back to the first entry document that they got, and then they're going to actually decide the roles of each individual in the groups. I'm going to call them expert groups, one role at a time, and using specific the worksheet that is specific to each role. I'm going to train them on their specific expertise and share the resources that we have. I'm going to explain the expectations and what they're going to do with the rest of the group and share their information, and then they're going to return back to their teams. And then again, these are just some of the sheets that will be given them that they can show and know the resources of what they will be doing and what they'll be sharing back with their group. Stage 5 is that the teams are going to work in collaboration to create a prototype for the solution. So when all the students return to their original teams as experts in the area to solve the problem, they're going to begin the timer and monitor student groups to ensure that they're working together and within the design criteria and constraints. Once the students have planned their design, they're going to build, test, and refine it as needed. During the building phase, the project manager begins planning the presentation and communication of the solution. And then you can see stage 6 is the actual presentations and evaluations. I have a rubric set aside on the next slide that I'll show you. But upon completion of the design and the group presentation, the project manager leads the group in completion of the rubric and distributes individual rubrics to each team member to complete. And then each student will be given the individual student rubric based on their own participation, and that looks like this. So they'll be grading themselves based on creativity, what they learned from their mistakes, any new ideas that they created, and then their evidence and conclusions. So that is it for the PBL on gravity and the new science standards. So just to kind of reiterate and go over it a little bit, what they need to understand is they need to support an argument that the gravitational force exerted by Earth on objects is directed down. Another key understanding is the gravitational force of Earth acting on an object near Earth's surface pulls that object toward the planet's center. And these are going to the essential question that why doesn't gravity pull in all directions? And the task itself, just one more time, is just to solve the problem and create a parachute that will allow a hard-boiled egg to land without the cracking. And then the rubrics are attached on the side, and they came up during the presentation. And these are just listed out of the steps.